Okay, so I had some audio issues with that last recording, so I'm going to try to re-record my audio over the video that I recorded earlier, so hopefully this will work out. So the situation that we're in now is that we have an infinite series, and we're still asking the question, will this series converge or diverge? However, inside of the series now, we have an x value, and the question is, what x values could we plug in here that would give us a series that actually converges? For example, if I plug x equals 0 into this series, every single term in the series goes to 0. And I would get 0 plus 0 plus 0 an infinite number of times, and that series would converge to 0. The question is now, what are the other x values I could plug into this series that would give us a converging series? To do this, as you can see up here on the screen, we're going to use the root or the ratio test, and the ratio test is the most common test that we're going to use to do this. And when it comes to the ratio test, what we're going to do is we're going to take the term inside of our series and replace n with an n plus 1, and that's going to be our numerator. And then in the denominator, we're just going to put the term that's inside of that series. Now we need to simplify. We need to divide these two fractions. That's a copy.flip kind of a thing. And somewhere off to the side, we can write it down, or maybe we can think it. X to the n plus 1 can be written as just x to the n times x. The two powers on x on the right-hand side are n and 1. And when we multiply these together, we add those powers to get x to the n plus 1. What else? N plus 1 factorial. Well, that is just n plus 1 times the number below it, times the number below that, and so on. So we can rewrite n plus 1 factorial as n plus 1 times n factorial. If we do those two things, what you'll notice is you get a whole lot of cancellations. The x to the n's cancel, and the n factorials cancel. We need just one more line of room to finish this thing up. If we now take our limit as n goes to infinity, you'll notice that our x value is fixed, but our denominator is going to infinity. That means that our limit is going to be 0, and by the ratio test, if this limit is less than 1, our series converges. What that means is for any x we choose in this original problem, our ratio test is always going to give us a limit of 0, and our series is always going to converge. So this series all the way up here converges no matter what x we choose. It converges for all x values. We might write that as negative infinity to infinity. We might write that with a fancy capital R for all real numbers. Or we might say that our radius of convergence is 0. All of those mean that this series converges for all real x values. And that does it for this problem. Let's do another one in the next video.